So in this video, I'd like to talk about transactions. Transactions are a very important concept in reality for databases because they involve operations that happen at the level of applications that use the database, and a very common feature of existing databases is that operations are going to be done by multiple users at the same time, running in parallel. Now, the trick with transactions is that while they're an application level operation, they're a single operation at the application level, they often involve multiple database operations to complete them. Okay, so we've got this notion of a single thing happening in the application, but it requires several things to happen underneath, if you like. So, for example, if I wanted to book a seat on a plane, this is a very common kind of application. First thing you've got to do is find a flight. Once you've found the flight, you then want to check whether, are there any seats available. So we have to do availability check, and then if we find a seat available, then we can book it. And the operation that's going to happen in the database is we're going to add a tuple that says this passenger has booked this seat. And potentially we've got a bunch of tuples in the database already, one for each seat on the flight. Some of them have passengers attached to them already, some of them don't. So the operation of allocating a seat might be simply an update operation. Next thing we have to do is, and that would be allocating an empty seat. So the other thing we have to do before we do that, we've got to find which seat is empty. So we've checked whether there is an empty seat available, we find that seat, and then we allocate it. And then we have to indicate, of course, that there's one less seat available on this flight. And potentially there's a counter somewhere that says how many available seats, and that's the counter that we would use up here to do the availability check. So that's potentially 3 and maybe even 4 database level operations. Here we do a query to see how many available seats are there on the flight that we've chosen. We then find a seat that's not yet allocated. That could be a query. That could potentially be an extra operation in here. So find an available seat, then allocate that seat to the passenger who's making the booking, and then tell the system that there's one less seat available. And when that eventually falls to 0, it makes this availability check easy, and we can say, all right, there are no more seats on the flight. Another common kind of operation that involves multiple database operations, but which conceptually is a single application operation, is transferring funds between bank accounts. So from account 1 to account 2. We should put a line through there, being a separate operation. So once again, this involves multiple operations. First thing we've got to check, do we have enough funds? So presumably this is initiated by saying, I want to transfer X amount of dollars from account Y to account Z. So do we have sufficient funds to actually make the transfer? So let's assume the bank doesn't want to allow overdrawn. So that's going to be a query on the database. Next thing is to remove the money from the source account, which let's say it's account 1 in this scenario, and add the money to the destination account. To account number 2. Okay, so once again, that'll be a query operation, that'll be an update operation on account 1, and this will be an update operation on account 2 to make the transfer. So the funds that used to be in there are now in here. So a single operation doing a transfer of funds composed of 3 separate database operations. A single operation of application level operation of booking a seat on a plane. This one's actually, I've got 4 operations involved in that, 4 database operations. Okay, so that's okay as far as it goes. Let's take a look, however. Let's call this operation here C for check. Let's call this one find. Let's call this one allocate, and let's call that one decrement. So reducing the number of seats by 1. So we've got 4 database operations that make up the single operation of booking a seat. So to book a seat, for 1 person on 1 flight, we perform the operation C, then F, then A, then D, in that order. So a sequence of operations to accomplish that overall effect. So if we got a single person using the system at a given time, those operations will run and everyone's happy. But if we've got multiple people trying to book seats at the same time, there are some potential problems that can arise. So let's call each of these sequences of operations a transaction T, and I'll use subscripts to indicate different transactions. So sort of standard seat booking transaction is CF, A and D. Now let's say that we've got 2 transactions that come along almost at the same time. And let's say the operations happen in this order, and I won't bother writing the semicolons, but this is a sequence of operations. As we go across the screen here, that's increasing time. So that's the first thing that happens, second, third, and then the second transaction, I said it was at the same time, but operations never happen exactly simultaneously. Both transactions are doing this, and there's going to be some interleaving of the operation. So let's say that T2 manages to do those, and then T1 runs again and does the decrements, and then T2 finishes its operations. Is there going to be any problem there? Probably not, because if there are multiple seats, there's certainly not going to be a problem. Both of the checks will say there are seats available. The finding a seat, this will find 1 seat, this will find presumably a different seat, and it'll certainly find a different seat because it's looking for an unallocated seat, and T1 actually did the allocation before T2 started work. Now the only time where there could potentially be a problem here is if this is the last seat, or if we're allocating the last seat, this operation here will be performed before we've indicated that there are no seats left. So this might say, oh, there seems to be 1 seat left, all right? Let's find it. And it'll look through the table of seats, looking for an allocated seat, but it won't find one because it was already allocated by T1. So at this point, this transaction will actually fail and say, oh, there are no allocated seats. So these 2 operations are actually never going to happen. So having T2 reached this point and given up because there are no seats available on the flight, it will then decrement and set the number of seats to 0. So anyone who comes along in future, when they perform this operation, they'll give up straight away and say, oh, there are no seats left on the flight. Okay, so let's take a look at what happens with a slightly different order of operations. So I'll rub them off. Okay, so T1 checks and finds an empty seat. T2 checks and finds an empty seat. T1 allocates and decrements. T2 allocates and decrements. This is a possible interleaving. You can have an arbitrary number of possible interleavings of the operation. We could have C, C, F, F, A, D, D, or any other kind of combination. So, T1 comes along, checks whether there are seats, finds an empty seat, fixes the, eventually fixes the allocation and then decrements. In the meantime, T1 having found an empty seat, T2 comes along and checks and discovers there are available seats. If there's more than one available seat, then T2 might find a different seat to the one that T1 found. And that would be very nice if that happens. So then we allocate and decrement and allocate and decrement. So the allocate is actually updating the seat that we found in the F statement. If the classic scenario is that there's a single seat left on the flight, T1 comes along, he checks and he finds that seat. Then T2 comes along, checks, there's still one seat apparently available. He finds that seat as well. T1 allocates the seat to the first passenger and decrements the counter. Then T2 allocates the same seat to a different passenger and decrements the counter again. So we actually have two problems. One is that the counter's gone negative, which doesn't make sense, but the other problem is that this passenger's allocation has been overwritten by this allocation. So that is clearly not a desirable scenario. And if you allow arbitrary interleaving of the operations within transactions, that's the kind of thing that can happen.